Hey gang, welcome to the seventh video in our Rust for Beginners series. In this video, we will learn about functions. Before we jump into it, if you guys haven't subscribed to the channel, please do so as it helps me a lot. If you guys have found the content interesting and would like to see more, please smash the like button and share with your friends who would benefit from this. Let's get into it. So functions are a core part of the Rust language. We have already seen one of the most important functions in Rust, the main function, which is the entry point for many programs. You have also seen the fn keyword, which allows you to declare new functions. As with variables and projects, Rust uses a snake case convention style for function names. This means all letters are lowercase and underscores separate words. Let's look at the sample function program. First, create a new project using cargo new. Okay, let's remove this. First, let's create a new function. And new function is fn. Now here we've defined a new function called another function. We define a function by in Rust by entering fn, followed by the name of the function, followed by parentheses, and then the curly brackets. Now, if we want to let's run this code and see how it goes. So as you see, now as you can see, it ran as we expected it to. Now we can call this another function in the main function by writing the name of the function followed by parentheses. Here we've defined another function after main function, but it doesn't really matter. You can also define it before. All that matters is that it can be in the same, it should be in the same scope as the call-in function. Now the lines are executed in order as they are written. First println will execute, and then another function will execute. Now parameters. We can define functions to have parameters, which are special variables that are part of a function signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in conversation, people tend to use the word parameters and arguments interchangeably for either the variables in a function's definition or the concrete values passed when you call a function. Let's change our program a little bit. So here, another function has a parameter called x. The type of parameter is defined as i32. Now, in the main function, we are passing 5 to another function. And the println macro will put the value of x, that is 5, in the output. Now, because In function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust's design. Requiring type annotations in function definitions means the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful errors if it knows the types the function expects. Now, say for example, let's run this program first. Okay, now say for example, instead of 5, let's pass a string. Now immediately I get an error here. Arguments to these functions are incorrect. Now, so this means that x can only take a I32, but if we change this to a string type, now it will run. Now, if we have multiple parameters, let's change. Let's add something else. 5. We define multiple parameters, separating the parameter declarations like this. So you put y I32 comma x string literal. Now if we run this code, so as you expect, value of x is Rust and value of y is 5. Statements and expressions. Function bodies are made up of a series of statements, optionally ending in an expression. So far, the functions we have covered haven't included an ending expression, but you have seen an expression as a part of a statement before. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinctions, so let's look at what statements and expressions are and how their differences affect the bodies of functions. Statements are instructions that perform some action and do not return a value. Expressions evaluate to a resultant value. Let's look at some examples. We've actually used statements and expressions before. Like, say, for example, let's delete this. Now, this statement, let y equal to 6, is a statement. This does not return a value. Function definitions are also a statement. This entire code base is also code block is also a statement. Statements do not return a value, therefore you cannot assign a let statement to another variable. I'll show you what this means. We cannot do let x equal to this is an error. Let's try running this. This statement expected an expression, but we got a statement instead. The let y equal to 6 does not return a value, so there is nothing for x to bind to. Expressions evaluate your value and make up most of the rest of the code that you will write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value of 11. Expressions can be part of the statements. The 6 in y equal to 6 is an expression, just the 6. Calling a function is an expression. Calling a macro is also an expression. A new scope block created with curly brackets is an expression. For example, let's change. I'll show you what I mean by this. So this code will run if we. So now this block, let x equal to 3x plus 1, is an expression which evaluates to 4. That value gets bound to y as part of the let statement. Note that x plus 1 does not have a semicolon at the end, which is unlike most of the lines you have seen so far. Expressions do not include semicolons. If you add a semicolon to the end of an expression, you turn it into a statement and it will not return a value. Keep this in mind as you explore function return values and expressions next. Now, functions with return values. Functions can return values to the code that calls them. We do not return values, but we don't return values, but we must declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of the function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here is an example of a function that returns a value. There are no function calls, macros, or even let statements in the 5 function, just the number 5 by itself. This is a perfectly valid function in Rust. Note here that we have defined the function's return value, which is i32. Now, there are two important bits in this. The line let x equal to 5 shows that we are using the return value of a function to initialize x. That means we are using the value returned by this function to initialize x. Because the function 5 returns a 5, that this line is equivalent to writing let x equal to 5. Second, the function 5 has no parameters and defines the type of return value. But the body of the function is a lonely 5 with no semicolon because it is the expression whose value we want to return. Now let's just run this and see how it goes. Oh, save the code, guys. Yeah, as we can see, the value of x is 5 as what we expected. So the code will execute this first. We'll call this function. This function returns a value of 5, which is saved in x, and then x is printed here. Now let's take a look at another example. Now in this function, now in this code, we are calling the function +1, which takes a parameter of i32. and returns an I32. So what it does here is it accepts a value, adds one to it, and returns it back to the calling function. So let's run this so you guys can get a better idea. See if I save this. The value of 6, which is what we expected. But now, for example, if we put a semicolon here, my editor immediately throws an error. Let's run this and see. Now, because we had mentioned that the type of return type for the function is I32, we will have to return an I32. But here, when we put a semicolon, we are returning a unit type. And therefore, nothing is returned, which contradicts the function definition. To fix this, all you have to do is remove this, and the code will compile again. So that's pretty much the end of this video, guys. Please do like, share, and subscribe if you found the video interesting. See you again in the next video where we'll be looking at comments.